You pull a ton of dull, gray rock out of the earth, shatter it, and somehow extract a glowing, highly valuable precious metal. By the end of this breakdown, you will know the exact step-by-step mechanics of an all-sliming gold cyanidation circuit, a precise sequence capable of extracting over 90% of the trapped gold from raw ore. We are also going to cover how modern facilities execute a zero-equipment change upgrade that entirely removes toxic chemicals from this workflow. Looking at this dashboard, you can see the prerequisites. Before you begin, you need a standard setup of wet grinding CIL or CIP equipment, specifically a crusher, ball mill, thickener, leaching tanks, and dilution columns, along with your baseline chemical reagents. Mastering this specific equipment sequence turns basic mechanics and chemistry into massive, consistent profit. Step 1 is mechanical reduction. We start by feeding the raw gold ore through a crusher, breaking the large rocks down to uniform 12mm chunks. Next, those crushed chunks enter the ball mill for wet grinding. Here, water is introduced to create a slurry. You need to hit a strict target ratio of 1 part ore to 3.5 parts water. This flowchart displays our closed-loop safety net. A classifier analyzes the slurry output. Any ore particles larger than 50 micrometers are caught and looped continuously back into the mill until over 90% of the material is fine enough to pass. During this grind, we introduce quicklime. The standard dose is 4 kilograms per ton of ore. Notice the data tag dropping to 1.6 kilograms. You achieve that reduction simply by reusing your process wastewater, cutting your quicklime input down to 40%. Finally, we pump this ground slurry into a thickener. The goal is to separate out the excess water until the mixture reaches an exact 1 to 1.5 slag to water ratio. If you fail to hit these specific physical dimensions and chemical balances, the gold remains permanently trapped in the rock during the extraction phase. Now we reach the chemical extraction. As the thickened slurry enters the first of 10 leaching tanks, we add our leaching agent, traditionally 400 grams of sodium cyanide per ton of ore. This diagram shows the forward motion of the slurry. It cascades sequentially from left to right through all 10 tanks, continuously stirring over a 16-hour period. At the same time, we initiate a countercurrent. We inject activated carbon starting at the 10th tank, forcing it to flow backwards, right to left, through a series of carbon-separating screens. Zooming in on the screen interface, you can see the carbon moving in direct opposition to the slurry. We dose the carbon at 680 grams per ton. By keeping the carbon isolated in the screens, it fully reacts with the passing liquid, capturing the dissolved gold, without getting lost in the raw mud. This 16-hour phase yields precise results, an 87.88% leaching rate and a 99.2%. We take that raw slime through pyrometallurgy smelting. The extreme heat burns away impurities, leaving a composite gold product over 80% pure. While the gold is being smelted, the barren slurry left over from the tanks, the tailings, is pushed through a press filter, squeezing the waste down to a dry 20 to 22% moisture content. Every drop of extracted wastewater from that press filter is captured and recycled straight back into the cyanidation stage. The entire circuit operates with supreme efficiency. You reuse the water continuously, while the isolated atoms are forged into highly pure wealth. However, this traditional setup has a glaring vulnerability. Relying on sodium cyanide introduces severe toxicity risks, massive wastewater treatment costs, and constant regulatory friction. To solve this, many modern plants upgrade to Jinchan metallic ore dressing agent, a high-performance, non-toxic alternative. Looking at this side-by-side setup, the primary operational advantage is clear. You drop Jinchan into the exact same pumping configuration. There is absolutely zero need to change your existing tanks, screens, or flow sheet. Making this simple substitution maintains, and often improves, your overall leaching efficiency, while instantly drastically slashing your wastewater treatment overhead. Long-term operation requires survivability. Using green chemistry guarantees local regulatory compliance and worker safety without sacrificing your bottom line. That completes the circuit. You have successfully navigated the process from a raw, micro-ground slurry to a fully smelted product. This 3-panel view represents the final outputs of a well-run modern plant: high-purity composite gold, a safe and easily managed pile of dry-stacked tailings, and a perfectly closed-loop water system. If you are ready to evaluate your own circuit for this eco-friendly upgrade, Click the link to calculate the exact Jin-Chan dosing requirements for your specific ore profile. True mastery of metallurgy means maximizing your extraction yield while leaving zero toxic footprint behind.